Hello everyone, welcome back to our part 4 video lecture for module number 4. So shear and moment diagram. So we have here number 2 from your module, a simply supported beam carrying a load cis of naught at point B. Okay, so we have here a moment of cis of naught at point B, and it is simply supported by a pin at A and a roller at C. So we need to determine our shear and moment equations and draw our shear and moment diagrams. So before that, since I have here a roller, we will be having two reactions, which is vertical. So at first, I assume it to be upwards. Then I have here horizontal. Then for pin, I have here upwards. Okay, one reaction only. So to get the reaction, summation at moment A, all forces that are rotating clockwise should be positive. So I have here negative C rotating in a counterclockwise with a lever arm of L plus C of naught, because it is rotating in a clockwise manner, is equivalent to 0. Transpose this to the other side of the equation to make it positive. Then C is equivalent to C of naught over L. So C vertical is C of naught over L. Next, summation of forces vertical is equivalent to 0. All forces pointing upward should be positive. So what are those forces? So I have here my first assumption of the A vertical is upwards plus C of naught, and that's plus C vertical, and that is C of naught over L. So A vertical plus C of naught over L is equivalent to 0. Transpose this to the other side of the equation. Therefore, A vertical is equivalent to negative C of naught over L. Therefore, my assumed direction is incorrect. It should be pointing downwards. And C of naught over L is pointing downwards. Next, summation of forces horizontal is equivalent to 0. All forces towards right should be positive. But we only have A horizontal as our horizontal force. So A horizontal is equivalent to 0. Okay, so redrawing the free body diagram, I will be having my cutting plane at section AB. So this is my cutting plane A prime for segment AB. Then I have here B prime, my cutting section from segment B to C. So redrawing the free body diagram, this is segment AB. So I have here my A vertical. Then I also have my A horizontal. So this is A horizontal. Then I assume my shear to be upwards. So shear AV. Then my moment to be counterclockwise. Moment AB. Then I'll assign this point at point D. Okay. So summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? So we have negative C of naught over L plus shear AB is equivalent to 0. Therefore, shear AB is equivalent to C of naught over L. Next would be the moment. Summation of moment at point D is equivalent to 0. All forces that are rotating clockwise should be positive. So what are the forces that are rotating with respect to D? So I have negative C of naught over L times a lever arm of X minus MAB is equivalent to 0. Transpose this to the other side of the equation. MAB is equivalent to negative C of naught over L times X. Therefore, my assumed direction is incorrect. So C of naught over L times X, and it should be clockwise. Okay. Next would be segment BC. So redrawing the free body diagram of segment BC, it would look like this. Okay, so this is my cutting plane B. So I'll assume shear to be upward pointing upwards, shear BC, then moment BC would also be in counterclockwise. Okay, so summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. Okay, so what are those forces? We have negative C's of naught over L plus shear BC is equivalent to 0. Therefore, shear BC is equivalent to C's of naught over L. Next, summation of moment with respect to, let's say this is E, point E. E is equivalent to 0. All forces rotating at point E in a clockwise manner should be positive. So I have negative C's of naught over L times a distance of x plus C's of naught, because it is rotating in a clockwise manner, minus MBC is equivalent to 0. Transpose this to the other side of the equation to make it positive. So MBC is equivalent to C's of naught minus C's of naught over L times a distance of x. Remember that for segment A, it is from 0 to 3 over 4 of L. So that is 0, then 3L over 4. That is for x. Then for this one, for our x value, we have 3L over 4 x, then we have here L. Okay, so we're now ready to draw our shear and moment diagram. Okay, so we're now ready to draw our diagram, shear diagram. So for segment AB, that is segment AB, our equation is C's of naught over L. So from A to B, it is C's of naught over L. So we have here at point A, we have a reaction of downward C's of naught over L. So this is C's of naught over L. Then from point A to B, it is still C's of naught over L. So that is straight line. Now, from segment BC, it is C's of naught over L. So there's nothing changing. So we have here C's of naught over L. Then at support C, you have there a C's of naught over L, and that is positive, that is pointing upward, so it will simply go back to 0. So let's verify whether we have here a 0 slope. So the derivative of shear with respect to x is equivalent to the load. But do we have a change of loading here, or do we have a load here? It is 0. Therefore, the slope of our shear diagram is 0. Okay, so our diagram is correct. Next, we now have our moment diagram. So for the moment diagram, we have here from segment AB, it is C's of naught, negative C's of naught over L, C over L. So from 0, if x is 0, at x is equivalent to 0, MAB is equivalent to C's of naught over L times 0. It is 0. At x is equivalent to 3L over 4, we have MAB is equivalent to C's of naught over L times 3L over 4. So L will cancel out, so we have here 3 C's of naught over 4. Okay, so we plot that. We have, if at x 0, At x is 0, it is 0. Next, at x equal to 3L over 4, it is 3 Cs of naught over 4. So that is 3/4. Okay, so we simply connect it by a straight line. So we know from the previous previous video, if this is 0 degree, the succeeding diagram would be a first degree. So it is a straight line. Okay, now at segment BC. So at x is equivalent to 3L over 4, MBC is equivalent to C of naught minus C of naught over L times 3L over 4. L will cancel out. Then 3/4. 1 minus 3/4 is equivalent to C of naught over 4. Okay, so at x is equivalent to L, MBC is equivalent to L. We have here C of naught minus C of naught over L times L. L will simply cancel out. C of naught minus C of naught is equivalent to 0. So from negative 3, C of naught over 4, it will go up to positive. So we have here C of naught over 4. Then at a distance L, MBC is equivalent to 0. So 0 degree, then therefore the next diagram would be a first degree. So I have here C of naught over 4. And this is now my moment diagram. So shear diagram, moment diagram. So this is 0 degree, this is first degree. Now let's check what is the slope for this one. So the derivative of the moment with respect to x is equivalent to the shear. Okay, so what is the shear? So the shear here is C of naught over L, and it is negative. So it is pointing downwards. So you have here C of naught over L is to 1. Then for this one, itong segment na to, the derivative of moment with respect to x is equivalent to the shear, and that is still negative C of naught over L. It is still pointing downwards. So that so the slope is still C of naught over L is to 1. And this is your shear diagram. This is my shear diagram, negative. This is my moment diagram, first degree.